Okay, question 5. Find the matrix that represents a reflection in the line y equals minus x. You may remember this, you may have learned which one this is, but if not, we go to the formula booklet. Reflection in the line y equals tan theta x is given by that matrix there. So we're looking for y equals minus x. That means that tan theta is equal to minus 1. Great. So what value of theta gives us minus 1? Inverse tangent of minus 1, we get minus 45. Okay, so that means theta is represented by minus 45 degrees. That would work in our thing. And so the matrix is cos, well hang on, it's cos 2 theta, sine 2 theta.
This is in degrees, isn't it?
Well, as long as you're consistent, it's up to you what it is. So that's the matrix that represents it, where theta is minus 45. So that's the matrix cos minus 90, sine minus 90, sine minus 90, minus cos minus 90. Which is quite an easy thing to work out. Stick it in the calculator, or just remember from the graph, cos of minus 90 is 0.
1.
Sine of minus 90. Oh, hang on, no, is that right? Yeah, it is right, isn't it? Yeah. Sorry. Sine of minus 90
Minus 1.
will be minus 1. So that's minus 1. So that we've got 0 as well. And there it is, 0, minus 1, minus 1, 0. Cool. 2 marks. Yes,
Do you
Alex?
not use that method where you look at the 2 points and move them? Always
Yeah.
Is that what worked for?
No, you could have done that as well. So think about where the 2 points would end up.
Is that using the unit square?
It kind of is using the unit square, but it's thinking of the point, well, the point 1, 0 ends up on that column, and the point 0, 1 ends up on that column. So 1, 0, if you're reflecting it in the line y equals minus x, you've got to work out where would it end up. 1, 0 would end up at 0, minus 1. So there's 0, minus 1. Does that make sense? You're thinking. So the first column is where that point ends up, and the second column is where that point ends up after the transformation. So the blue point, the first point, ends up reflected down to there, 0, minus 1, and that point ends up there, minus 1, 0. And so you could think about it that way, and that saved you a little bit of time if you think of it that way. The matrix C is given by that. So C is the matrix 1, 0, 0, 4. Okay. Again, we do have some choices about how we would work this out. You can multiply by the unit square. But again, you've got that idea that sticking with what Alex just said, that after the matrix, after the transformation, the first column is where that point would end up. So the point 1, 0 ends up at 1, 0. The second column is where the point 0, 1 would end up. So the point 0, 1 ends up at 0, 4, up there somewhere. And let's think what would have happened to it. Well, I mean, we could multiply, if you wanted to, multiply by the whole unit square. But I think we've got the idea of what's going to happen. That point's staying put, but that's going up that way. It's stretching it, scale factor 4, in the y direction. Parallel to the y-axis. Okay. You can also, if you want to, remember we talked about doing a unit square, so doing 0, 0, 1, 0, 0, 1, 1, 1, and multiplying that by that matrix and seeing where that ends up. And you would get 1, 4 of that other point that would be up there. And then you'd know it was a stretch in that direction. So that's it. That's gone as our 2 marks for that. State the value of the determinant of C and describe briefly how this value relates to the transformation represented by C. Well, let's work out the determinant of C. The determinant of C is, remember how we do this? We're going to do 1 times 4 minus 0 times 0. So that gives us a value of 4.
Is that the area resolution? Oh.
It's the scale factor of the area of the image. That's it. The scale factor of the area of the image. Okay. That's it. And that's always what happens. So the determinant of our transformation matrix tells us about the scale factor of the area of the matrix after the transformation. Happy? Ish. As I say, we'll do a bit more in my class with the transformations of graphs at some point. Transformations of matrices. And that's maths.